Hi dear students, welcome you all to the Brilliant group of institution. Today we are here to discuss the CBSE Class 12 Chemistry, the most important MCQ from the chapter P block elements, group number 15, 16, 17 and 18. Okay dear all, so let's start from question number 1. Here we have the question. First one, why does nitrogen show poor tendency towards catenation? You know what is meant by catenation? It's an ability, it's a self-ability of an atom to make a bond with their own elements. Like, carbon can make a bond with their own element like carbon, single bond, double, triple bond. Like, so carbon having high catenation power. But why nitrogen? Nitrogen, why not forming nitrogen bonds, even though nitrogen, why they are not existing in different form of like allotropes? So the two reasons, two question, one answer. Why nitrogen not forming catenation or less ability? Another one, why nitrogen not forming allotropes? The reason is what here all? Option D, nitrogen single bond is weaker one. Why nitrogen bond is weaker? You know that if you consider a nitrogen atom, they having 5 valence electron. Same another nitrogen atom, 5 valence electron. They can make a single bond, covalent bond, but you can see that what each nitrogen carries 2 lone pair. Lone pair repulsion is greater one, so they will repel each other. The nitrogen bond get weak one. Alright, understood? So nitrogen are not ready to make a individual bonding, means catenation. So the answer is nitrogen single bond is weak one. Question number 2. What is the maximum covalency of the nitrogen atom? Nitrogen atom, what is the maximum electron it can give during a chemical reaction? Nitrogen atomic number 7, its configuration 1s2, 2s2 and we have 2p3, right? It can donate electron from the p orbital completely, the 3 electron it can donate, and from s orbital mostly it is donating just 1 electron. Okay, from s orbital it's donating 1 electron, p orbital maximum donating 3 electron, so total it can donate 4 electrons. So maximum catenation or the covalency of the nitrogen is around how much? Option D, 4. Okay, option 4. Option 4th one, D, 4 is the correct answer. Now, why it is donating only maximum 1 electron from s orbital? S orbital maximum contain 2 electron, but why they are donating only 1 electron? Because nuclear charge is greater. The nitrogen 7, this 2s orbital is not far away, that's very nearby. So s orbital completely you cannot donate maximum. It is that's also rare, but maximum you can donate 1 electron from s orbital. So s orbital 1, p orbital 3, total that's covalence is equal to 4. Question number 3. Which gas is released when copper chips are subjected to nitric acid? So copper strips, when you are reacting with nitric acid, HNO3, what is going to get here? Copper when react with the nitric acid, you will get copper nitrate, CuNO3 twice, nitrogen dioxide along with the water. So which gas? Which is the gas here? Nitrogen dioxide. What is the state of nitrogen here? What is the oxidation state of nitrogen here? 4, right? Because if you don't know nitrogen, take it as X. 1 oxygen charge is -2, 2 oxygen charge is -4. Overall it is a neutral compound, so the sum is equal to 0. So X equal to +4. Alright. So nitrogen is in 4th oxidation state. So what we can say? Nitrogen 4 oxide. Nitrogen 4 oxide. Option D is the correct answer. Let's go to the next question. What shape is the HNO3 molecule in its gaseous state? Here on nitric acid, how is the existence? Very simple. Nitric acid existence is like this here on. 1 hydrogen, 1 oxygen, then nitrogen, a double bond oxygen, a single bond oxygen. This is the normal structure of nitric acid in gaseous state. Here, what is the geometry? Here we can see that it's just like a triagonal planar geometry. Nitrogen, if you consider it as the central atom, it's having a oxygen, OH. So here it's having generally it having a trigonal planar geometry. So we can go with the answer C. Where in nitric acid, you know that the central nitrogen carries a positive charge, the single bonded oxygen carries a negative charge. So electrically it's neutral one, but still HNO3, the formal charges on nitrogen is positive, on the single bonded oxygen is negative. Okay, let's go to the other one. Which of the following ion is the brown ring test useful for determining? You may carry out this reaction in laboratory also. Brown ring test we are using to detect what? Nitrate ion. Yes or no? Nitrate ion. Nitrate ion. What is nitrate ion? NO3 minus, right? NO3 minus, option B. I'll tell you brown ring, what is the equation, everything in one of the other question. Next one. What catalyst is used for the oxidation of ammonia to produce nitric acid? You may study the preparation of nitric acid from ammonia. What is the equation? Oxidation of ammonia, dear student. Oxidation of ammonia. What is meant by oxidation? Addition of oxygen. You may study that it is carried out around 800 degrees Celsius in the presence of a catalyst. What is a catalyst? Platinum rhodium gauge. Platinum rhodium gauge. So here, when ammonia treated with the oxygen, or oxidation of ammonia will happen, we will get mainly nitrogen monoxide, water along with the heat. It's an exothermic one. So nitrogen monoxide and water is the production. So what catalyst is used for the oxidation of ammonia to produce nitric acid? Nitric acid production is not completed, some more reactions are there. This is the steps for the oxidation of ammonia. So what is the catalyst using? The question here on platinum rhodium catalyst. Okay, platinum rhodium which we are using. Option C is the correct answer. Next one. What is the oxidation state of nitrogen in dinitrogen trioxide? What is the formula of dinitrogen N2 trioxide O3? What is the oxidation state of nitrogen? If you don't know the oxidation state of nitrogen, take it as X. There are 2 nitrogen atoms, therefore 2X plus. 1 oxygen oxidation state is -2, so 3 oxygen minus 6. Overall it is a neutral compound, 0. So 2X is equal to 6, X is equal to plus 3. So what is the oxidation state of 1 nitrogen? X equal to plus 3, option C. Very simple to calculate oxidation state, correct? Next one. Which of the following compound can be used to obtain free nitrogen atom? Free nitrogen. Which is the best method to get a free nitrogen molecule here? Very simple. The answer is NaNO2, sodium nitrite. You know, NaNO2, this is not a single step, 2 processes are there. When NaNO2 treated with ammonium chloride, when sodium nitrite treated with ammonium chloride, first of all you can obtain ammonium nitrite and NaCl. NH4NO2 and HCl. Sorry, not HCl, sodium, right? Sodium is the NaCl. Ammonium nitrate and NaCl. Not over, this produced ammonium nitrate. This produced ammonium nitrate, we have to again heat. This produced ammonium nitrate, on further heating, it will give you nitrogen along with the water. This is the production of best preparation of nitrogen, that is from NaNO2, sodium nitrite. Okay, first of all, sodium nitrite heating with the ammonium chloride, you will get ammonium nitrate. Ammonium nitrate on heating will get nitrogen gas. Next question dear all, why does nitrogen show anomalous property with respect to other elements in group 15? You know the main reason, if you consider nitrogen family element, nitrogen, phosphorus, arsenic, antimony and bismuth, when you consider, you know nitrogen, in every group the first element shows some anomalous property like small size, high ionization enthalpy, high electronegativity. The main thing is absence of d orbital. Yes or no? You know that in every group the first element doesn't contain d orbital. Because of that, so many things are different, especially oxidation state is different, their forming compounds are different, everything. So the major reason what's the anomalous property of the first element, especially nitrogen here in this group, that is because of what? absence of d orbital. That is a major anomalous property, and because of this absence of d orbital, all other property changes. Next one. Why is nitrogen preferably used in welding process and cooling of substances? You know, nitrogen at room temperature or the normal condition, it is inert gas. Because of that, why nitrogen inert gas? You know, nitrogen are connected through a triple bond. Triple bond is a very strongest bond. You cannot break it faster. So nitrogen is inert. It is a silent one. It is not ready to react under normal room temperature. Next one. What is the one method of qualitatively analyzing a given salt for presence of ammonia? Dear student, I am giving you a compound of ammonia and I am asking you that the presence of ammonia, how can we determine? Dear all, ammonia presence is determined by a small reagent is called Nessler's reagent. Alright? Ammonia presence is determined by Nessler's reagent. Okay, Nessler's reagent. What is chemically Nessler's reagent? Nessler's reagent is nothing but it is an alkaline solution. It is an alkaline solution of potassium tetraiodomercury. Tetraiodomercury 2 oxidation state. So if you keep in mind, ammonia in a compound you can easily identify by using with or treating with the Nessler's reagent. Nessler's reagent is chemically, it is an alkaline solution of alkali mixed solution of potassium tetraiodomercury 2. The formula we can write that K2HgI4, like K2HgI4. This is called potassium tetraiodomercury 2, where mercury is in 2 oxidation state. Alright, what is the reaction means when this reagent, what is the reagent, Nessler's reagent? K2HgI4 plus treated with the ammonia sample plus. I told you it is an alkaline solution. So let me add one of the alkali, potassium hydroxide also. So it is going to give you OHG2NH2. OHG2NH2I. This is a complex having a brown color. It's having a dirty brown color. If you are getting the dirty brown colored substance, you can confirm that yes, the given compound contains ammonia. So keep in mind, all of you, ammonia is determined by using the chemical that is called Nessler's reagent. What is Nessler's reagent? Alkaline solution of potassium tetraiodomercury. Okay, so answer is which one? Option C, using a reagent to obtain dirty brown precipitate. What is the reagent we are using? Nessler's reagent. Okay, next. Which of the following conditions would improve the yield of ammonia during Bosch-Haber process? You may study Haber process for the preparation of ammonia, right? Industrial preparation. N2 plus 3H2 gives 2NH3, and you know it is an exothermic reaction. Haber process is a heat releasing process, exothermic reaction. You know that it is a reversible process. Haber process is a reversible process. What is the catalyst we are using here? What is the catalyst we are using in Haber process? They are all iron, and we are using a molybdenum. You know, here iron used as the catalyst to speed up the reaction, and molybdenum used as a promoter. What is meant by a promoter? Promoter is a chemical substance which can increase the activity of an enzyme. To speed up the activity of an enzyme, that is called promoter. You may study the temperature, everything 773 like that. Temperature, pressures are required. Here all, if you want to improve the yield of ammonia, what we have to do in temperature and pressure? You know that where is ammonia located on the product side? So which reaction you need? Forward reaction, right? You need more forward reaction. So what are the factors which can increase the forward reaction in temperature and pressure? You know already it is a exothermic reaction. If you want to carry out a forward reaction, For an exothermic reaction, you have to decrease the temperature. If it is an exothermic reaction, if you need a gain forward reaction, you should decrease the temperature. What you have to do in pressure? Pressure dependence according to Le-Chatelier principle depends on the number of moles, number of particles. You know how many, all are gases, right? Nitrogen is a gas, hydrogen is a gas, the product ammonia is a gas. Pressure only affects on gases system. Yeah. Left side total, how many moles are there? Total, there are 4 moles. How? You can see 1 nitrogen, 3 hydrogen. Total 4 moles are there. Right side total, how many moles are there? Only 2 moles. 2 moles. Generally, when you increase the pressure of an equilibrium reaction shift from higher number of moles to lower number of moles. What? Generally, in a reverse reaction or in an equilibrium reaction, when you increase the pressure of the system, reaction shift from higher number of moles to lower number of moles. So here, if you increase the pressure, what will happen, dear student? It is shifting from 4 moles to 2 moles. Yes, forward reaction takes place. So what are the best conditions to get maximum amount of ammonia during Bosch-Haber process is what? Decrease the temperature, increase the pressure. Decrease the temperature, increase the pressure. Low temperature, high pressure, that is the best condition. Next question. Which of the following is true regarding nitric acid? Nitric acid is a strong reducing agent. Yes, student? Yes. It is a weak oxidizing agent. No. Nitric acid is a, please note it all of you, nitric acid is a strong oxidizing and reducing agent. Nitric acid is a strong oxidizing and reducing agent. Its basicity is unity. What is meant by basicity of an acid? We discussed now what is the structure of nitric acid. HO, N double bond O, O. What is the meaning of a basicity of an acid? It is the ability of or the number of H plus ion donated from OH group. You can see there is an OH group, right? From which it can donate H plus ion. How many H plus ion? Only 1. Therefore, the basicity is equal to 1 for nitric acid. Yes, unity. Once again, what is meant by basicity? It is the number of H plus ion leaving from OH group. Okay, OH group. And it is a non-planar in gaseous state. Which of the following is true regarding nitric acid? Right? True regarding nitric acid. It is a strong reducing agent. True. Its basicity is unity. Yes. It is non-planar in gaseous state. We studied no. HNO3. It's having a planar geometry. That also can be wrong. So it is a weak oxidizing agent. That can be. It's a non-planar in gaseous state. That also can be the answer. Okay. So which is true, right? Which is true. So it is a strong reducing agent. Its basicity is unity. Yeah. Option A and C are correct. Next one. Which of the following reagent or reaction best represent the lab scale preparation of nitric acid? You may study in the preparation of nitric acid. It is from sodium nitrate. Sodium nitrate, when you treat it with the sulfuric acid, you will get nitric acid in good yield. This is the best method for laboratory preparation of nitric acid by the reaction between sodium nitrate and sulfuric acid. What is the name of the industrial process to manufacture nitric acid is known as? Yes, student. Contact process, that is taught in your syllabus. Anyway, contact process is an industrial preparation of sulfuric acid. Haber-Bosch process, just we discussed, it is an industrial preparation of ammonia. Solvay process, it is a preparation of sodium carbonate. And Ostwald process is the preparation of which one? Nitric acid. Yes, nitric acid industrial preparation is called what? Ostwald process. Okay, Ostwald process. What is the nitric acid water composition by mass respectively for the component to form an azeotrope? This is a question relating P block and solution. We studied that nitric acid and water. Nitric acid and water we discussed as one of the example in which deviation they are all negative deviation. Correct? Negative deviation. In which we studied 68% nitric acid mixing with the 32% nitric water. It will give you a azeotrope. So that is the answer B. Next, which of the following reacts with the PCl3 to form PCl5? A small reaction in your textbook, it is given PCl3, you know, it is a gas. It is reacting with the 2 more chlorine atom and it is forming what? PCl5. PCl5. Right? So what is that? In order to convert to PCl3 to PCl5, what the reagent you require? That's Cl2 only. Right? Option D. Yes, simple question. Now, which of the following is the most stable one? What are the elements given? Arsenic, antimony, phosphorus and bismuth. So nitrogen family element. You know, nitrogen, phosphorus, arsenic, antimony, and we have bismuth. What the compound they given? Their chlorides are given. Okay, their chlorides. So for example, you know, NCl3, PCl3, ASCl3, SbCl3, BiCl3. Their chlorides are given here. Okay, now, which of the following is most stable? Dear student, okay, they given the pentachlorides, right? Not trichloride, they given pentachlorides. Okay, let's take it. Pentachloride. NCl5, PCl5, Cl5, this one. NCl5 we can cancel because we know NCl, nitrogen with a +5 oxidation state, not exist. NCl5 is not an existing one. NCl3 existing one. You know, in phosphorus, what is the oxidation state here? Here it is in +5. This is also +5. This is also +5. This is also +5. You studied that inert pair effect. What is inert pair effect? You know, nitrogen family elements can show general 2 oxidation state, +5 and +3. +5 and +3. You know, the topmost elements except the nitrogen, it can show +5 oxidation state. Down the group it comes to +3. How it is showing +5 oxidation state? You know the general electronic configuration of nitrogen family NS2NP3. NS2NP3. If it donating electron from both P and S, it shows +5. If it donating only from outermost 3, then it is called +3. That which meaning when you coming down the group, S orbital electrons are not take part in bonding. Is or no? While you coming down the group, S orbital electrons are not take part in bonding. Why? Due to inert pair effect. You may study that. Due to inert pair effect. What is mean by inert pair effect? The reluctance of S orbital electrons to take part in bonding while coming down the group. Okay, now as per that, which compound is highly stable, dear student? You know, all systems are in +5 state. In +5 state, which element will be stable? At the topmost one, which is that PCl5. Okay, PCl5. So the stability of +5 oxidation state decreases down the group. So topmost element shows +5, below element +3 is the common oxidation state. Alright, next one. What is the hybridization of phosphorus in PCl5? You may study very well about PCl5 geometry. It's having a trigonal bipyramidal geometry. Right. Here, how to find out hybridization? Very simple. Hybridization you can calculate by the sum of sigma bond and lone pair on the central atom. You please count how many sigma bond and lone pair on the central atom phosphorus. How many sigma bond here are? 1, 2, 3, 4, 5. Any lone pair you can observe on phosphorus? No. So total sum is equal to what? 5. If it is equal to 5, what is meant by hybridization? Hybridization is the mixing of, intermixing of atomic orbital, sp,d, etc. How many type of s orbital you have? Only one s orbital. You will write only one, right? How many type of p orbital you have? 3, right? What are they? px, py and pz. How many type of d orbital you have? There are 5 type of d orbital. dxy, dyz, dxz, dx square minus y square and dz square. Yes or no? So if your hybridization sum, if it is equal to 5, you take the first 5 orbital. Please take first 5 orbital, means 1 s orbital, 3 p orbital, 1 d orbital, total 5. So what is the hybridization? sp3d, right? sp3d. So answer is option C. If you want hybridization of the central atom, just to take the sum of sigma bond and lone pair, you will get a value like 4, 5, 6, etc. That much orbital you mix it from the beginning onwards. Alright, that's it. Next one. How does PCl5 exist in its solid state? Dear student, PCl5 generally can exist in all of the states, like first one, in liquid state or in gaseous state they exist in one form, and in solid state it existing in another form. How PCl5 existing in the liquid and gaseous form? It is a normal structure what we studied, trigonal bipyramidal geometry. Trigonal bipyramidal geometry. You know that these three are called equatorial bond. The upper and below is called axial bond. Axial bond are longer than equatorial bond. That everything you know. In liquid and gaseous state, what is the structure here? Trigonal bipyramidal geometry. Trigonal bipyramidal geometry. But in solid state, we are all PCl5 in solid state exists as ionic solid. It exists as what? Ionic form. Ionic means cation anion will be there. What is the cation? PCl4 plus. This is the cationic part. PCl6 minus. This is the anionic part. You know, this is the cationic part. This is the cationic part. This is the anionic part. What is the shape of cation? One phosphorus connected to 4 chlorine, which means it having a tetrahedral geometry. Tetrahedral geometry. In PCl6 minus, one phosphorus connected to 6 chlorine atom, that is to octahedral geometry. Okay, octahedral. They can ask you in PCl5 in solid state, what is the structure of cation? Tetrahedral. What is the structure of anion? Octahedral. Okay, dear all. So what is that? How does PCl5 exist in solid state? Your answer is what? Option A. PCl4 plus PCl6 minus. Next, what is the range of the oxidation state shown by phosphorus in its oxoacid? You may study so many oxoacids of phosphorus, like you know H3PO2, H3PO3, H3PO4, and HPO3 thrice, and we have H4P2O7 and the polymer also. What is H3PO2 is called? You know, hypophosphorus acid. H3PO3 is called orthophosphorus acid or phosphorus acid. H3PO4 is called orthophosphoric acid or phosphoric acid. HPO3 thrice is called the cyclic one. H4P2O7 is called pyrophosphoric acid. Right. Here all, what is the range of the oxidation state of phosphorus? So, in this oxoacid, what is the maximum, lowest to maximum range of oxidation state which is shown by phosphorus? Here all, that is +1 to +5. Maximum +1 to +5 oxidation state can be possessed by which one? The phosphorus in its oxoacid. Now, which of the following is incorrect about hypophosphorus acid? What is hypophosphorus acid? That is H3PO2. H3PO2. It is also called phosphoric acid. No, phosphoric acid is which one, dear student? H3PO4. Okay, so this is the correct answer. The oxidation state of phosphorus is +1 in this compound. Let me check it. What is the oxidation state of hydrogen? +1. 3 hydrogens are there? 3. Phosphorus we don't know, X. 1 oxygen -2, 2 oxygen -4, overall 0. Yes, X equal to +1. Correct. It is a monobasic one. You may study the structure of hypophosphorus acid. What is that? P double bond O, OH, and we have HHC, H3PO2, H3PO2. You can see what is meant by basicity of an acid. It is the number of H plus ion donated from the OH group. You can see there is an OH group. This hydrogen can be donated. So its basicity is what? +1 or 1. It's a monobasic one. Yes. It is represented by the formula H3PO2. Yes, all are correct. The only incorrect statement is bonds does hypophosphorus acid contain? Just I said you what is the hypophosphorus acid. Here on, let me just draw the shape of each hypophosphorus acid. One is H3PO2, one is H3PO3, the other one is called H3PO4. Let me write the shape, the name also. This is known as hypophosphorus acid. H3PO3 is called orthophosphorus acid or phosphorus acid. H3PO4 is called orthophosphoric acid or phosphoric acid. The other one that is called HPO3 thrice, and we have H4P2O7. HPO3 thrice is a cyclic compound. It is known as cyclotrimetaphosphoric acid. Cyclotrimetaphosphoric acid. H4P2O7 is called pyrophosphoric acid. Pyrophosphoric acid. Alright. Let me draw the shape of the first three acids now. Very simple. What is the meaning of a phosphorus acid? Phosphorus acid should contain a particular group common. What is the particular group common? P double bond O, OH. This is fixed. This thing, one phosphorus central atom, double bond O, OH. This is fixed in every phosphorus, the oxoacids. Okay, one hydrogen over, two oxygen already over, remaining hydrogen make it single bond. All of them having a tetrahedral geometry also. Okay. H3PO3 means what? P double bond O, OH is common. One more oxygen is required, right? Take it as OH. Remaining one hydrogen. So here what will be that? P double bond O, OH, OH, OH. Alright. Okay, fine. Now we can go for trimetaphosphoric acid. I think trimetaphosphoric acid, one of the questions we have to discuss. Then I will explain the structure. So how many pH bonds are present in hypophosphorus acid? How many pH bonds here on? 2 pH bonds are, right? 2 pH bonds are there. So if you know the structure of the compound, then only we can able to answer this type of question. Next, what is the basicity of pyrophosphoric acid? What is pyrophosphoric acid formula which I said? The last one, H4P2O7. Let me draw the shape, okay? There are two phosphorus, right? Okay, one phosphorus, other phosphorus. I told you each phosphorus contains double bond OH common. Double bond OH common. Now, so 2 hydrogen over, 2 more hydrogen you require, remaining extra hydrogen you can take it as OH and OH. So 4 hydrogen over, 2 phosphorus over, and 6 oxygen over, 1 more oxygen extras. So let me take it in the center as a bridging. Now you can see all of them having a tetrahedral geometry, right? Each phosphorus in the oxoacids of phosphorus, each phosphorus is in tetrahedral geometry, and also one more thing, each phosphorus connected to 4 groups. 4 groups, yes or no? That is tetrahedral. Fine. What is the basicity? Basicity means, I told you again, I am saying that it is the number of H plus ion donated from the OH group. Or you count how many OH groups are there. From this OH group, you can donate this H plus, this H plus, this H plus, this H plus. So total 4 H plus ion you can donate. So basicity is 4. That is known as tetra basic. Okay, tetra basic. So pyrophosphoric acid is tetra basic in nature. Next one. What is the total number of atoms or groups surrounding each phosphorus atom in its oxoacid? Just I said now. Each phosphorus in an oxoacid contain which one, dear student? At least 4 groups around, because it is a tetrahedral geometry, right? This group is common, this can be different. So total there will be 4 groups or atoms surrounding each phosphorus. Option is D. Next. Which of the following compound has phosphorus in +1 oxidation state? Let me calculate H3PO3. What is H3PO3? 3 hydrogen atom, 3. Phosphorus oxidation state X. 1 oxygen -2, so 3 oxygen -6, overall 0, X is equal to +3. H3PO4, 3 hydrogen 3, 1 phosphorus X. 1 oxygen minus 2, 8 oxygen minus 8, 0, x is equal to plus 1. Now, H3PO2, 3 hydrogen 3, phosphorus X, 1 oxygen minus 2, 2 oxygen minus 4, overall 0. Yes, here it is equal to plus 1. Option C. In which case, phosphorus is in plus 1 oxidation state, right? Option C is the correct answer. Next one. Which is the most abundant group 16 element? Which is the most abundant 16th element? What are 16th element? Oxygen, sulfur, selenium, tellurium, and we have polonium, right? Which is the most abundant group 16 element? That is what? Oxygen, right? Oxygen, which is around 23 percentage of the atmosphere. 23 percentage by weight of atmosphere is which one? Oxygen. So read very carefully, dear student, the occurrence of the elements in the NCERT textbook clearly given. So oxygen is the most abundant group 16 element. What is the general outer electronic configuration of oxygen family? You know, oxygen, when you consider atomic number 8, that is 1s2, 2s2, 2p4. Correct. If you are coming to sulfur, it will come to finally 3s2, 3p4. Next one, 4s2, 4p4. So generally what we can say, ns2, np4. This will be the general electronic configuration of oxygen family, ns2, np4. Now, which of the following does not exist in an octa-atomic solid? Octa, 8 atoms together. What is that? Oxygen. Did you see a molecule like O8? O8? No. But did you see a molecule like S8? Yes. We studied no. Rhombic sulfur and monoclinic sulfur. Alpha sulfur and beta sulfur exist as S8 unit in a crown structure. Yeah. Why oxygen not forming octa-atomic solid? You know, oxygen is a diatomic one, right? Oxygen exists as O2. Why oxygen making 2 atoms together? You know, oxygen contain only the final orbitals are p orbital. So it can make which orbital? P pi overlapping. It can make a pi bond between them. So from one oxygen, one pi bond, the other oxygen, another pi bond can make a overlapping, sidewise overlapping. It can create a pi bond between them. Oxygen, there is a chance to make which one? P pi bonding. So it is exists as diatomic. But this is not possible in other elements like sulfur onwards. It is not possible. So what they will do that, in order to maintain stability, they are trying to make ring compounds. You know, S8, how it is existing, right? S8 exists as a crown structure. Yes or no? Exists with a crown structure. So why they are existing in a ring form? To attain stability. Alright, so what is the reason here on why oxygen exists as diatomic? You know, diatomic, they are gases, and sulfur acid as solid. Why? Because oxygen can make only p pi multiple bond, so it is a stronger bond, it exists as diatomic. But solid, why sulfur S8 something exists as solid mean they are bigger atomic masses, at the same time sulfur having no ability to make p pi multiple bond, so they are trying to exist in mostly ring form to attain stability. Next one, which group 16 element has the highest tendency for catenation? You consider the 16 group element oxygen, sulfur, selenium, tellurium, polonium. Which group elements having a high tendency for catenation? You know, catenation means the ability, we discussed in nitrogen also. Catenation means the ability of an atom to make a bond with their own element. So it is maximum for, dear student, sulfur. It is maximum for sulfur. Why oxygen not forming? You know, oxygen bond, same like nitrogen. Two oxygen atom when come closer, there will be lone pair repulsion. There will be lone pair repulsion, greater bond get weaker one. But sulfur is little bigger size, at the same time they have a ability to make very stronger bond also. It is not possible down the group, right? Down the group, size of the atom very high, bond become very weak. So high catenation power, therefore sulfur exists as S8 form, S6 form, etc. because their bonding is little stronger. Next one, what is the most stable oxidation state of the oxygen atom? You know, oxygen generally exists in different 3 states. Like generally they exist as oxide. Most of the compound they exist as oxide. Very few compound they exist as peroxide. Very few compound they exist as which one? Superoxide. Yes or no? Superoxide. What is oxide? Oxide mean oxygen atom is in -2 state. Peroxide mean one oxygen atom is -1 state. Superoxide mean one oxygen atom is in -half oxidation state. Yes or no? Which is the common oxygen oxidation state? -2. Right? -2. Next question, all of you. What is the nature of zinc oxide? Zinc oxide, it is actually a metallic oxide. Metallic oxides are generally basic in nature, but zinc oxide, ZnO, aluminium oxide, Al2O3, they are what? Amphoteric oxide. Okay, amphoteric oxide. They can react with both acid and bases. Keep in mind, zinc oxide and aluminium oxide are generally amphoteric in nature. Now, which of the following method is used to form ozone from oxygen? You may study the preparation of oxygen. How you can prepare ozone from oxygen? Very simple. The oxygen gas, a dry stream of oxygen gas, you can pass through a electrical discharge. What? Silent electrical discharge. When a dry stream of oxygen gas, when you pass through a electrical discharge, a silent electrical discharge, you will get ozone, O3. It is an endothermic process. Okay, endothermic, heat absorbing process. Here all oxygen, dry stream of oxygen, you can pass through a very a silent electrical discharge 1, discharge 2, then it is converted to ozone. It is an endothermic reaction, which meaning delta H value is a positive value. Preparation of ozone is an endothermic reaction. Option B is the correct answer. Next, an ozone transition from solid to liquid to gas. What is the notable color change? Dear all, ozone can exist in their gaseous form, in their liquid form, in their solid form. They are having different color. In gaseous state, what is the color of ozone? You may study that it's having a pale blue color, right? It's having a pale blue color. But in liquid state, it's having little bit dark blue in color, right? A deep blue, or we can say a dark blue in color. What about solid? In solid state, they exist as violet dark, very dark in color. So the intensity increases when they come from gas to solid. So ozone transition from, they are saying solid to liquid, liquid to gas. So what we can say, violet to deep blue or dark blue, then to pale blue, right? Option D. Yes or no? Solid state, it is violet to dark, and in liquid state it is deep blue or dark blue, and it is in gaseous state it is pale blue in color. So properties are important. Why is ozone a powerful bleaching agent? Ozone is thermodynamically unstable, right? Ozone is thermodynamically unstable. Ozone immediately converted to oxygen molecule and nascent oxygen. Right? You may study why ozone is thermodynamically unstable, everything. During this reaction, entropy will be positive. This is an exothermic reaction, like that. This is an exothermic reaction, so delta H is negative. Finally, gives energy when you apply the equation delta H minus T delta S. Overall delta G become negative. Gives energy negative, mean reaction can be happen feasible or spontaneous. Yes or no? So what we can say, here the question is entirely different. Why ozone used as a powerful bleaching agent? What is the reason? The nascent oxygen. The nascent oxygen is the one which is interacting with the bleaching substances and everything, and it converted into a colorless one. So the nascent oxygen is responsible for the bleaching action of which one? Ozone. What is the chemical structure and formula of sulfur? Simple one. What is the chemical structure? I told you sulfur exists as octaatomic, S8. And what is the formula sulfur? S. Right? S8 and sulfur. What is the transition temperature of alpha and beta sulfur? You may study that. What is alpha sulfur? Alpha sulfur and beta sulfur. Right? Alpha sulfur and beta sulfur. You know, alpha sulfur is also known as what? Rhombic sulfur. Beta sulfur is also known as what? Monoclinic sulfur. Right? Rhombic and monoclinic. Now, alpha sulfur property, everything you may study. Alpha sulfur is bright yellow color. Beta sulfur is light yellow color. Alpha sulfur is preparing from rolled sulfur. Beta sulfur is preparing from, or monoclinic sulfur is prepared from rhombic sulfur, alpha sulfur. And both are insoluble. Both alpha and beta allotropes of sulfur are insoluble in water, but small extent they can soluble in organic solvent like benzene. And both are highly soluble in carbon disulfide CS2. And you may study alpha sulfur is stable at room temperature, beta sulfur is unstable at room temperature. The main thing you may study, the alpha sulfur or our rhombic sulfur, you can convert it into monoclinic sulfur, that is our beta. Similarly, monoclinic you can convert it into rhombic. You know, rhombic sulfur, when you heat it about 369 Kelvin, when you heat a rhombic sulfur at 369 or above at 369 Kelvin, you can convert it into monoclinic sulfur. Monoclinic sulfur on cooling, you can get back rhombic sulfur. So this transition is happening at what temperature? 369 Kelvin. So rhombic sulfur you can convert it into monoclinic sulfur at the temperature 369 Kelvin. This this temperature is said to be what? Transition temperature. Transition temperature. When you see this value 369 Kelvin, immediately you will go to the option A. Without looking the unit, you directly will go to the option A. But very careful, both option A and B are wrong. Both option A and B are wrong. Why? 369 Kelvin is the answer, but they given 369 degrees Celsius and degree Fahrenheit. What is the answer here? Option C, 95.9 degree. If you add 95.9 degree plus 273.15, if you convert into Kelvin, it is equal to 369 Kelvin. Alright, option C is the correct answer. Now, what is the basicity of peroxodisulfuric acid? You may study the 3 oxoacids of sulfur. What are the oxoacids of sulfur? H2SO3, H2SO4, H2S2O7 and H2S2O8. Yes or no? These are the oxoacids of sulfur. What is H2SO3 is called sulfurous acid. H2SO4 is called sulfuric acid. H2S2O7 is called pyrosulfuric acid or called oleum. H2S2O8 is called peroxodisulfuric acid. H2SO3, what is the shape? S double bond O. Sulfur is there, sulfur which contain double bond O, and we have OH, OH. You can see H2SO3 and sulfur, there is a lone pair. The lone pair containing only one oxoacid of sulfur is, we are discussing in 12th grade, that is H2SO3 sulfurous acid. What is H2SO4? H2SO3, H2SO4, only the excess is one oxygen. Instead of lone pair, that also you make it as oxygen, that's it. OH, OH. This is called pyrosulfuric acid, or you studied that oleum, fuming sulfuric acid, right? 2 sulfur are there, 2 sulfur. Each sulfur contains double bond O, OH. Double bond O, OH. H2 over, 2 sulfur over, 6 oxygen over, 1 oxygen at the center. H2S2O7. In only H2 pyrosulfuric acid and peroxodisulfuric acid, when you consider 1 oxygen extra, the extra oxygen, same like here, double bond O, OH, double bond O, OH. There are 2 oxygen, you can make it in between oxygen here. 2 oxygen, that is a peroxide. You know, oxygen linkage is called what? Peroxide linkage, right? Peroxide. So question, what is the basicity of peroxodisulfuric acid? What is basicity here all? The number of H plus ion donating from OH group. Total there are 2 OH group, so those H plus ion you can donate. So basicity is 2. Basicity is 2, right? Next. What is the basicity of oleum? What is oleum, dear all? Oleum is H2S2O7. What is its basicity? It also can donate these two H plus ion from the OH group. Its basicity also 2. Alright? Simple one. What is the correct order of the enthalpy of dissociation of halogen? The dihalogens are given here: fluorine, chlorine, bromine, and iodine. We know fluorine is the most electronegative element, so we are thinking fluorine-fluorine bond is a very stronger bond. Very big mistake. You know that one fluorine having 7 valence electron, right? 7 valence electron, and they will make a single bond. Where see lone pair, each fluorine contain 3 lone pair. It's having high electron-electron repulsion. So fluorine-fluorine bond get elongate. It is a weakest bond. So which bond? What is the order of? What is the order of the enthalpy of dissociation? Bond enthalpy. So which bond is the greatest bond? I will give a simple idea to remember the bond dissociation enthalpy for halogens. You please make, or you please fill the or place the fluorine in between bromine and iodine. If you need the order of the bond dissociation enthalpy of halogen family, please put the fluorine in between bromine and iodine. Your answer is ready. So which is the greatest one? Chlorine. Greatest one for chlorine, then bromine, then what? Then fluorine, then we have iodine. This is the order. Okay? Chlorine first, then bromine, then fluorine, then only iodine. So what is the correct answer? Chlorine, bromine, fluorine, iodine. Option B. What is the reason why fluorine going to the second last one? Because fluorine-fluorine bond is the weakest bond due to more electron-electron repulsion. So as experimental, this is the correct order of bond dissociation enthalpy. Next one. Fluorine exhibit oxidation state only -1, whereas other halogens can show +1, +3, +5, +7, etc. What is the reason? You know, every element on the top in a group, the first element, if you consider fluorine, chlorine, bromine, iodine, in every group, the first element doesn't contain d orbital, absence of d orbital. If an element having a d orbital, then only it can exhibit variable oxidation state. Fluorine can exhibit only one oxidation state, -1, except one of the acid, HOF. What is HOF is called? Hypofluorous acid. In hypofluorous acid, fluorine is in +1 oxidation state. Let me show you. Hydrogen oxidation state 1, oxygen oxidation state -2, fluorine oxidation state X 0, X equal to +1. So they are all. Fluorine generally exhibit only one oxidation state -1, except one of the compound HOF, hypofluorous acid. In this compound, fluorine is in +1 state. Why fluorine not showing variable oxidation state? And answer is the absence of d orbitals. Now, the only one oxo acid, just to be discussed now, the only one oxo acid which is formed by fluorine is which one? HOF, hypofluorous acid. The acidic strength of hydrogen halide varies in the order. You know the halogens are fluorine, chlorine, bromine, iodine. What is their hydrogen halide? HF, HCl, HBr, HI. You know, fluorine bonds all are stronger. Fluorine, if it making a bond with the other element, all are stronger except fluorine-fluorine bond. We said no. Fluorine-fluorine bond is the weakest bond due to electron repulsion. But fluorine, when it is making a bond with the other element, it is highly exothermic reaction, which means the bond is very strong. HF bond is very strong. When you coming down the group, halogen size increases, the bond get very weak. Yes or no? HF bond is a very strong hydrogen bonding. This is a very stronger bond. This is weak bond. So the question is acidity. Yes or no? Acidity. You know, acidity means its ability of a species to donate H plus ion. If it donating H plus ion so easily, we can say that it is highly acidic in nature. So which is ready to leave hydrogen faster? HI, because the bond is weaker. So down the group in hydrogen halide, acidity increases. So what is the answer here on? HF, HCl, HBr, HI. Option B is the correct answer. Next one. What is the boiling point of hydrogen halide? If you consider HF, HCl, HBr, Hi. Again I am saying that HF bond is the stronger bond. Yes or no? This is the stronger bond because fluorine is more electronegative, hydrogen is electropositive. They will bond be very strong. But Hi is a very weak bond. The question is related to which one? Boiling point. Boiling point order, there is an experimental data. Okay, dear all, for boiling point, boiling point mainly depends on two factors. Boiling point of a species mainly depends on two factors. One is their molecular mass. Higher the molecular mass, higher boiling point. Second reason is what? Intermolecular forces. Intermolecular force of attraction. Intermolecular force of attraction. Force also very important. HF having very stronger bond, but Hi having very big mass. See, sorry. HF having very stronger bond, Hi having very higher mass. So what's the confusion? So as per the data, as per when they considering both of the two factors for the boiling point, they got the idea. HF having greater because of very stronger bonding, HF. Then we have Hi. Then we have Hi. Okay, keep in mind all of you. Boiling point order. First HF. Why? Because of stronger bonding. Then Hi. Because of what? Weak bonding. Weak bonding, not weak bonding. Greater mass. Okay, greater mass. So after that, same order. So HF, Hi, HF, Hi, HF, Hi, which is coming under option A, HF, Hi. After that, we are considering HBr mass only, then HCl. So keep in mind all of you, HF, when you consider the boiling point of a system, two things you have to consider. One is its molecular mass, one is their force of attraction. Greater force of attraction is for HF, so for that one, and greater mass is for Hi, so that is the second. Option A is the correct. Now, interhalogen compound, for example, ICl. Interhalogen compound means it is the bond between two different halogens. This is more reactive than their relative elemental halogen like fluorine, chlorine, etc. Why interhalogens are very highly reactive, dear student? In interhalogen compound, iodine and chlorine both are different halogens. They have a large difference in their electronegativity, so the bond becomes weak. There is a large difference between their electronegativity, so the bond is weak. But if the bond is connected to the same halogen, there is no large difference in the electronegativity. Bond can be little strong, except fluorine. Okay, fluorine bond, it is the weakest bond. If you consider chlorine bond something, the bond will be little stronger one. So why generally interhalogen compounds are more reactive mean their bond is weaker, and dihalogen, their self-halogen compounds are little stronger except fluorine. So what is the answer? Due to the weak X dash, halogens are generally expressed by the letter X. So interhalogen compound we want to write X and X dash because two different halogen. Same halogen you can write either X with the X or X dash with the X dash. Same halogens. So what is the correct answer? X dash bond is weaker. X dash bond is weaker than XS bond. Option D is the correct answer. What is the acidic strength of the oxoacids of halogens varies in the order. What is the oxoacids of chlorine? HClO, hypochlorous acid, HClO2 or HClO2 or HO2Cl, that is called chlorous acid, and we have HClO3, chloric acid, and HClO4 is called perchloric acid. What is the acidic strength? Acidic strength is related to the oxidation state. Higher the oxidation state of the central atom or the halogen here, especially the halogen, which are oxoacids you are considering. Here I am considering the oxoacids of chlorine. So if the chlorine oxidation state is greater, mean acidity also greater. You can check the oxidation of chlorine. Here it is +1, here it is +3, here it is equal to plus 5, here it is around plus 7. Or higher the oxidation state, higher acidity. What is the point? Higher the oxidation state, higher acidity. So this one greater, greater, greater. So what is that? We can say HClO4 is the greatest one, then HClO3, then HClO2, HClO. Option D is the correct answer. Okay, so greater the oxidation state, greater will be the acidity. Okay, next one. When HCl react with the finely powdered iron, it form only ferrous chloride. When HCl react with the iron, Fe react with the HCl, you will get only which one? Ferrous chloride. What is ferrous chloride? FeCl2 along with the hydrogen. FeCl2. This is called ferrous, right? This is called ferrous or ferrous chloride. Not ferric. What is ferric? FeCl3, right? FeCl3, ferric. You know, in ferrous, iron is in 2+ state. In ferric, iron is in 3+ state. So, Fe, or I can say that instead of FeCl, you are not getting FeCl3. Instead of that, we are getting only FeCl2. What is the reason? Here, suppose I want to convert FeCl to FeCl3. +2 oxidation state want to convert into +3. How +2 oxidation state converted to +3? By losing one electron, right? Lose of electron. Losing electron is called what? Oxidation. So ferrous, if it want to convert into ferric, actually oxidation want to take place, but it is not happening. Why? You can see the byproduct is what? Hydrogen. Byproduct is what? Hydrogen. What is hydrogen? It is a reducing agent. Reducing agent, it will not favor this oxidation process. So what is the answer, dear student? Liberation of hydrogen prevent the formation of ferric chloride. Liberation of hydrogen prevent the formation of ferric chloride. Okay, next. What is the geometry of ClF3 and BrF5? ClF3, you may study very well ClF3. You can apply VSE PR theory. You will get which shape here on? T shape, right? ClF3 having a T shape. And BrF5, bromine. Bromine valence electron is what? 7. It is connected by 5 fluorine atom. 5 fluorine. You know, each fluorine need 1 electron. So total there are 5 bond pair, 1 lone pair. 5 bond pair, 1 lone pair mean structure is square pyramidal. Square pyramidal. How to draw? Br. Make a square first of all. Make a square first of all. This is square. One of the fluorine pyramid, another lone pair. Square pyramid. So what is the geometry? ClF3 T shape. BrF5 is square pyramidal. Option B is the correct one. Next one. When excess of ammonia treated with the chlorine results dash. You may study the reaction of ammonia with the chlorine. Ammonia with which one? Chlorine gas. 2 reactions are there. Let me write. Ammonia plus Cl2 gives. Second reaction, ammonia react with the Cl2 gives. Well, what is the difference between the 2 reactions, right? In first reaction, ammonia is in excess quantity. In second reaction, chlorine is in excess quantity. Both are different. When you treat excess ammonia with the chlorine, you are going to get your own ammonium chloride along with the nitrogen gas. If you treat excess chlorine with ammonia, instead of ammonium chloride, you will get a explosive material that is called nitrogen trichloride along with the hydrochloric acid. Difference is there. Okay, careful. So when excess ammonia treated, we need the first equation. What is the forming product? Ammonium chloride. Option B is the correct answer. Next one. Chlorine water on standing results. You know chlorine water. Cl2 water. Chlorine water on standing. Chlorine water, when you keep it for a long time in a test tube, it is converted to 2 acid. One is hydrochloric acid, one is HOCl, hypochlorous acid. HOCl is called what? Hypochlorous acid. Here all. Okay, answer is you can say HClO. And one more thing. You know, chlorine is used for a bleaching agent, right? Why? This HOCl further splitted into what? HCl and nascent oxygen. We studied no? While ozone is used as a bleaching agent, it can give nascent oxygen. Similarly, chlorine, why it is used as a bleaching agent, it can also produce nascent oxygen. Next one. Which of the following is the exact product of this reaction? Gold. Gold based, I think only one of the reaction we are studying here with the aqua regia. You know what is meant by aqua regia, right? Aqua regia. It is a 3:1 percentage of which one two major acids are there, nitric acid and yes, hydrochloric acid. You know, hydrochloric acid and nitric acid, they are all, what all the ions are given by HCl, H plus and Cl minus. Nitric acid will give you two ion, H plus and NO3 minus ion. Yes or no? So what are the ions generally given by these two species? H plus is there, then Cl minus, then NO3 minus. What all ion here on? H plus is there, Cl minus is there, NO3 minus is there. This aqua regia you treat with your metal gold. You know, gold and platinum can dissolve in aqua regia. Let me take platinum also. Okay, platinum. What is the mixture contain? H plus, Cl minus and NO3 minus. Very simple to write the product. The byproducts are fixed. Byproducts are in both cases nitrogen monoxide and water. Nitrogen monoxide and water. What is the major product here? Major product is very simple. Gold when combined with the aqua regia, it will give you AuCl4 minus. Gold with the 4 chlorine. When platinum combined, you will get PtCl6 2 minus. Gold with the 4 chlorine with a minus 1. Platinum with the 6 chlorine with a minus 2. This is the forming compound, dissolved. So according to the reaction, gold, H plus, chlorine, NO3 minus. What are the product? AuCl4 minus, nitrogen monoxide, water. Answer is which one? Option B. Okay, next one. What is the correct formula of chlorous acid? Chlorous acid is which one, dear all? HClO2. What are the oxoacids of chlorine? HOCl, HO2Cl, HO3Cl or HO4Cl. Or you can say HClO, HClO2, HClO3, HClO4. HClO is known as hypochlorous acid. Hypochlorous acid. HClO2 is called chlorous acid. Just to cut hypochlorous acid. Chlorous acid. And HClO3 is called chloric acid. See, what are similar? Hypochlorous, chlorous, chloric. And next one is perchloric acid. Perchloric acid. Perchloric acid. So what is the chlorous acid formula? HClO2. Next one. How many Cl double bond or bonds are present in perchloric acid? Very simple to know the shape of oxoacids of any compound. Let me write once again. HClO, hypochlorous acid. HClO2, chlorous acid. HClO3, chloric acid. HClO4, perchloric acid. Very simple to write the structure here all. See all of you. One is common in every system. HOCl. Like a bend shape. This is common in everything. You can write like this. HOCl. 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 What is excess? First compound already over. HOCl over. In second compound, one oxygen extra. Extra oxygen, you please make it as a double bond with the chlorine. Extra oxygen, you make it as how many oxygens are extra that you make it as a double bond with the chlorine. That's it. So HClO3, two oxygen extra, right? So double bond or double bond. Here 3 chlorine oxygen extra. Double bond or double bond or double bond. So now come to the question. How many chlorine double bond or bonds are present in perchloric acid? Which is perchloric acid? HClO4. How many Cl double bond O? 1, 2, 3. There are 3 bonds. Correct. Next one. What is the geometry of IF7? Here all, iodine is the central atom. Halogens contain 7 valence electrons. It is surrounded by 7 fluorine atom, right? 7 fluorine atom. Each fluorine need 1 electron. So they will take total. There are 7 bond pair, 0 lone pair on the central atom. 7 bond pair, 0 lone pair, that is known as which geometry? Pentagonal Pentagonal, bipyramidal. Pentagonal, bipyramidal. Pentagonal, bipyramidal. How to draw the shape? Very simple. Iodine. Make a pentagon. 1, 2, 3, 4, 5. Pentagonal, bipyramidal. Option D is the correct answer. Next one. When platinum dipped in aqua regia, just we discussed in one of the question, gold when you dissolve in aqua regia, we will get 1 gold with a 4 chlorine with a minus charge. When platinum dissolved, what we will get? PtCl6 2 minus. PtCl6 2 minus. Option B is the correct answer. Now, which of the following compound is cannot formed by xenon? Xenon general compound we studied that which all compound XeF2, XeF4, XeF6, right? Another compound like XeO2F2, XeO3, XeOF4, etc. So many compounds are there. But we didn't study XeF5, XeF3, XeF. All of these compounds cannot be formed by xenon. Answer is option D. Why? You know, xenon is a noble gas. They contain 8 valence electrons. Xenon F5. F5 means there are 5 fluorine. If 5 fluorine connected, each fluorine 1 electron taken. 1 lone pair, you can see 1 odd electron. So when xenon combined with the odd number of the counter ion, counter species, what will happen? There 1 electron excess or odd. Odd electron species cannot complete their octet at all, so it will be unstable. So xenon combined with all even number of compounds. Option D is the correct answer. What is the condition to prepare XeF2? Xenon compound preparation you may study here all Xe plus F2, Xe plus 2F2, Xe plus 3F2, right? Xe plus F2 you will get XeF2, Xe plus 2F2 XeF4, Xe plus 3F2 XeF6. Yes or no? You may study the condition also. This is happen around 673 Kelvin. This is around 873 Kelvin. This is around 573 Kelvin. What is the pressure? 1 bar pressure, 7 bar pressure, 60 to 70 bar pressure. What is the condition? Another one. In first case, xenon should be in excess quantity. In first case, XeF2, if you want to prepare, xenon must be in excess. Here, 1 is to 5 ratio. Here, 1 is to 20 ratio is required. So, what is the condition to prepare XeF2? What is the answer? There should be 673 Kelvin, 1 bar, and xenon should be in excess. Yes, option B can be the correct answer. Correct. Next. What is the geometry of XeF4 and XeF6? Here on XeF4, we will draw like this. There are 4 bond pair and 2 lone pair. 4 bond pair and 2 lone pair. What is the structure is called? Square planar. Right? XeF4 having square planar geometry. But what about XeF6? Xenon, there are 8 valence electron. It is surrounded by 6 fluorine atom. Each fluorine need 1 electron. Total there are 6 bond pair, 1 lone pair. Normally 6 bond pair alone means we can write octahedral shape. How we can write Xe 1, 2, 3, 4, 5 and 6 octahedral shape. But there is a lone pair. There is a lone pair. If there is a lone pair on xenon, lone pair, bond pair repulsion will be there. The octahedral shape get disturbed. That is called what? Distorted octahedral shape. So we can say XeF4 is in square planar shape. XeF6 is in distorted octahedral, square planar and distorted octahedral. Option C is the correct answer. Next one. Xenon readily form compound with the fluorine and oxygen. We discussed now in one of the previous question. Here, you see xenon forming mostly compound with the fluorine and oxygen only, right? Why? The main reason in halogen. What are the halogen? You have helium, neon, argon, krypton, xenon, and radon. So down elements are xenon and radon. Radon no need to consider; it is a radioactive element. So the bottom element is which one? Xenon. Xenon having a bigger size. Bigger the size of the atom, it having lower ionization enthalpy, which means you can remove the outermost electron so easily. So it can undergo reaction. Why xenon forming compound with the fluorine and oxygen highly electronegative element? Because xenon having lowest ionization enthalpy. Lowest ionization enthalpy. Option C can be the answer. Alright. Now, partial hydrolysis of XeF6 result. You may study two type of hydrolysis in this chapter, or especially 18th group element, complete hydrolysis and partial hydrolysis of XeF6. Let me tell you what is the partial hydrolysis of XeF6. Two reactions are there. XeF6 when you reacted with the 1 water. What is the meaning of partial hydrolysis? You are limiting the amount of water. One XeF6 reacting with the 1 water molecule, XeF6 reacting with the 2 water molecule. What are the products? Let's see. XeF6 when you react, in both cases, byproduct is common, HF and HF. The major product is the only different. When XeF6 reacted with the 1 water molecule, it will give you XeOF4. When you treated with the 2 water molecule, it will give you XeO2F2. Okay, XeO2F2. This is what happened. So partial hydrolysis of XeF6 result, XeOF4 and XeO2F2. That is option B. Now, low boiling point shown by noble gases because noble gases having low boiling point. I told you boiling point is mainly depends upon the weight as well as molecular force. Here generally noble gases. So noble gases, they are connected. Noble gases are free to move. They are gaseous one actually. So they are connected through which bond? We studied that it's a weak van der Waals force. Yes or no? The weak van der Waals force means you can break it very fast within lower temperature. So boiling point is lesser. So why noble gases showing very less boiling point? That is because of weak van der Waals force. Which is the weak van der Waals force? Dispersion force of attraction. Dispersion force of London force, right? London force. Can we write dipole? No, dipole interaction is between two polar molecules. They are not polar molecules, right? So we can say that weak dispersion of London force. Now, XeF2 on hydrolysis. We studied the complete hydrolysis, right? We studied the complete hydrolysis. In the last question we discussed partial hydrolysis of XeF6. Partial hydrolysis we are studying only for XeF6, but complete hydrolysis we are studying for 3 systems. What are they? XeF2, XeF4, third one XeF6. All of them. Let me hydrolyze them. Hydrolyze means nothing but I'm now not balancing, I'm focusing on the major products. Okay. Let us add water. Completely they will hydrolyze. Very simple to remember. XeF2 on hydrolysis, that you remember all of you. That is xenon, hydrogen fluoride, oxygen. What happened? XeF2 on hydrolysis you will get xenon, HNF with oxygen. Same thing you repeat in the second reaction. Xe plus, HF plus, O2. One product is excess, XeO3. That's it. In last one product, you take only the 2 things from previous equation. That is HF and XeO3. This is the only product forming in the last one. So what is the question here? XeF2 on hydrolysis. What are the thing you will get? XeHFO2. XeHFO2. So but the confusion, 2 answers are there, option C and option D. Both xenon, HFO2. Let's balance it. Okay. They already given the LHS 2XeF2 with the 2H2O. Now let's balance. How many xenon should be there? 2Xe. How many hydrogen should be there? 4HF. Right? So what is the answer? Option D is the correct answer. Right? Xe plus HF plus O2. Now, what is the shape of XeO3? Very carefully, all of you prepare and study what is the compound structure. Okay? XeO3. Xenon is the central atom. 1, 2, 3, 4, 5, 6, 7, 8 valence electron. It is surrounded by how many oxygen atoms? 3 oxygen atoms. Each oxygen carrying 6 electron in their outermost shell. Okay, 6 electron in their outermost shell. So for oxygen atom to complete their octet, they need 2 more electrons. So let them take 2 more electrons. So 1 lone pair extra. Total how many bond pair and lone pair on central atom xenon according to BSE-PR theory? Total there are 3 bond pair and 1 lone pair. Why? Double bond, if it is there according to VSE-PR theory in 11th grade we studied that if there is a double bond, if there is a multiple bond, we have to consider it as a single bond. So there are 3 multiple bond, that is 3 single bond, 3 bond pair. 3 bond pair, 1 bond pair, that correspond to which one? Trigonal pyramidal geometry. Trigonal pyramidal geometry. How to draw the shape of XeO3? Xe at the center, double bond O, double bond O, double bond O, and lone pair. It's having a trigonal pyramidal geometry. Option D is the correct answer. Which of the following compound is isostructural? What is meant by isostructural? Same structure with ICl4 minus. First of all, let me calculate what is the shape of ICl4 minus. Here, which is the central atom here? Iodine. What is the valence electron? Iodine halogen 7. But you can see there is a negative charge. Negative charge means addition of 1 more electron. Okay, so 1 more electron let me add on central atom. Which is the surrounding element here? Chlorine. How many chlorine? 4 chlorine. 1, 2, 3, 4. Halogen need 1 more electron, right, to complete octet. So 1 chlorine take 1 electron. Okay, 1 electron. Total how many bond pair and lone pair? 4 bond pair, 2 lone pair. Structure is what? Square planar geometry. ICl4 minus structure is square planar. So which compound we studied before? XeF4. XeF4 having square planar geometry. Or you just look into the number of atoms, right? Square planar geometry. It's having a square planar geometry. 4 bond pair, 2 lone pair. Next one. What is the correct formula of Epsom salt? The existence of the species are very important here on oxygen family. Existence of sulfur they mention in textbook. Sulfur. Sulfur in the earth crust or an atmosphere, generally it exists as sulfate ores. Either they are sulfate ores or they are sulfide ores. Sulfate or sulfide ores. You know what is sulfate ion? Sulfate mean SO4 2 minus ion. Sulfide mean S2 minus ion. Right. What are the sulfate ores of sulfur? It's given in NCERT textbook, that is gypsum. Very familiar. Gypsum. Another one is Epsom salt. That is our question. And you have barite. Barite. Gypsum formula you may study. What is gypsum formula? Calcium sulfate 2H2O. Epsom salt is an ore of magnesium. Magnesium sulfate 7H2O. Magnesium sulfate 7H2O. Answer is option C. And barite is barium or barium sulfate. Coming to sulfide ore. Sulfide ores are, galena. Which one? Galena. Another one, zinc blende. Another one, copper pyrites. Copper pyrites. These are the sulfur existing ores in sulfide form. Galena is nothing but ore of lead. Lead sulfide. Zinc blende is zinc sulfide. Copper pyrite is CuFeS2. Okay, CuFeS2. Copper ore. So a correct formula of Epsom salt is which one, dear all? Magnesium sulfate 7H2. Next one. The oxidation state shown by group 16 element other than -2. Group 16 element oxygen, sulfur, selenium, tellurium, polonium. General oxidation state is -2. Other than that, it can show +2, +4, +6 oxidation state. Okay, +2, +4, +6. Very carefully read NCERT. Clearly given that. Now, what is the thermal stability of the hydride of 16th group element? 16th group element again oxygen, sulfur, selenium, tellurium, polonium. What is the hydride of oxygen? H2O, H2S, H2SC, H2TE, H2PO. Question: thermal stability. Thermal stability means depends on this bond strength. Higher the bond strength, higher thermal stability. You know which bond is very stronger bond? No doubt H2O, because oxygen is more electronegative element. It is having a very strong hydrogen bonding. While coming down the group, the anion charge, the size will very higher, so the bond become very weak. So which one having high thermal capacity? H2O. So top to bottom, thermal capacity decreases. So H2O, sulfur, selenium, tellurium, polonium. Option A can be the answer. Next one. What is the acidity order of the 16th group elements hydride? Yes, when I'm saying thing, I'm repeating. These are the hydrides of 16th group element. Which substance, acidity means its ability to donate H plus ion. Which substance is ready to donate H plus ion? That is nothing but polonium. Because H2O bond is a very stronger bond, it won't leave hydrogen easier. So top to bottom, bond strength is weaker, it can easily donate H plus ion, so acidity increases down the group. So what is the correct order? H2PO, H2 oxide, sulfur, selenium, tellurium, polonium, right? Option C can be the answer. So top to bottom thermal stability decreases, top to bottom acidity increases, because thermal stability, acidity are inversely proportional. Now SF6 cannot be hydrolyzed faster, it's due to. Here all we said sulfur generally existing SFO4 and SF6. SFO4 you can easily hydrolyze, means you can easily dissolve in water, but SF6 can't. Why? There is a exceptional property we may study in SF6 that is called steric reason. Answer is option B. Why? Here all, in SF6 sulfur is connected to 6 fluorine atom, right? Sulfur is connected to 6 fluorine atom, you can say in octahedral manner. So this sulfur, actually we are thinking sulfur connected to 6 fluorine atom, the 6 fluorines are highly crowded one, high electron repulsion, it is highly unstable, so they can easily undergo hydrolysis, but there is not an exceptional case is there. In SF6, sulfur is exceptionally protected by 6 fluorine atom. The 6 fluorines are crowded actually, and they are making, the 6 fluorine are crowded, sterically crowded the sulfur atom, it is protecting sulfur atom. So water cannot enter inside, it cannot break the bond, it won't dissolve in water fast. But in SF4, there is not that much protection. So careful all of you, in SF6, the sulfur, 6 fluorines are protected. 6 fluorines are protected for the sulfur atom. So it cannot undergo hydrolysis. The reason is called steric reason. Okay, steric reason. Now, sorry. Bond dissociation enthalpy. What is bond dissociation enthalpy? Amount of energy required to break the bond is given below. Which of the compound will act as a strongest reducing agent? What is the meaning of a reducing agent? Reducing agent means we can say that it can undergo oxidation. What is meant by oxidation? All examples are given in terms of hydrides. How you can say oxidation in terms of hydrogen? Oxidation means addition of oxygen, or we can say removal of hydrogen. Removal of hydrogen. So reducing agent means it can undergo oxidation. Oxidation means removal of hydrogen. So can I say if the substance is ready to remove hydrogen, it is strong reducing agent? Yes, right. So let me take, what is that hydrides are given? Nitrogen family. Nitrogen family are nitrogen, phosphorus, arsenic, antimony, bismuth. Nitrogen hydride is NH3, BH3, ASH3, SPH3, BiH3. You know which bond is very stronger bond? Nitrogen hydrogen bond will be very stronger bond because of high electronegativity of nitrogen. So down the group the bond become very weak. So who is ready to donate H plus ion faster? BiH3 because of weak bond. So that is the strongest reducing agent. Where is BiH3? BiH3 is not in the option. So next one which is there, SBH3, option B. You can check with their bond enthalpy also. I think SBH3 you can donate hydrogen easier, mean their bond enthalpy will be very less. You can check it. Yes, you see here on SBH3 bond enthalpy is 255 only, all others having very greater. Okay, so strongest reducing agent mean it is easy to donate H plus ion. Option B is the correct. Now, which of the following pair of ions are isoelectronic and isostructural? Isoelectronic means same number of electrons. Isostructural means same structure. Let me check. First one, ClO3 minus and SO3 2 minus. Here, which is the central atom here? Chlorine. What is the valence electron of chlorine? 7. Okay. You can see there is a negative -1 charge. So you can add one more electron, right? 7 is there plus one more electron because of minus charge. It is surrounded by how many oxygen atom? 3 oxygen atom. 1, 2, 3. Each oxygen carrying how many electron in their outermost shell? That is 6 electron. Yes or no? 6 electron. So they can make a double bond with which one? Chlorine atom. Okay. Now come to sulfur. Here sulfur is the central atom. What is the outermost electron of sulfur? 6. Oxygen family. No. 1, 2, 3, 4, 5, 6. But can you see there is a 2 minus charge? Add 2 more electrons. Okay. It is surrounded by how many oxygen atom? Again 3 oxygen atom. Okay. What is the oxygen valence electron? 6 are. Each oxygen needed 2 more electrons to complete its octet. Fine. This is the same situation here, right? See, number of electrons here, number of electrons are same in these cases. Okay. So it can be same structure also, right? Yes, each oxygen, if it's making a double bond, it's having a same structure. Almost it will get a structure like which one? Pyramidal structure like that, it can obtain. Now, isoelectronic mean, isoelectronic, let me count once again. ClO3, you know, one chlorine contain how many electrons? 17 electrons. One oxygen contain 6 electron, 3 oxygen contain, right? Here chlorine, are you clear what I am calculating? Number of electron in the overall system. Chlorine contains 17 electron. Alright? One oxygen contains 6 electron. Sorry, 8 electron. 6 electron is in which one? Carbon, right? One oxygen contains 8 electron. So 3 oxygen contain 24 electron. Then can you see 1 electron extra minus? Yeah, so add one more electron. So total 8 plus 2, 42 electrons are there. Let me calculate the electron in SO3 2 minus. Sulfur contain, what is the atomic number of sulfur? 16. One oxygen contain 8 electrons, so 3 oxygen contain 24 electrons. Okay, but minus 2 means gaining 2 more electrons, so add 2 more. So 16 plus 2, 18, 18 plus 24, that's equal to 42. Yeah, they have the same number of electrons, their isostructure also. Because the central atom contains 8 electrons, surrounding also same type. They can be same structural and electron. Option A. Which of the following acid form 3 series of salts? Here all are the oxo acid, you know, H3BO3. No, boric acid we didn't discuss about in 12th grade, right? That's in 11th grade we discussed. H3PO3, H3PO2, H3PO4, hypophosphorus, orthophosphorus, and orthophosphoric, which is from 3 series of salt. You know, H3PO2 structure we discussed, P double bond OH, then HH. H3PO3 we discussed, phosphorus acid, double bond OH, OH, H. And H3PO4 we discussed, P double bond OH, OH, and OH. Yes or no? Here we can say which can form 3 series of salt, which means which one can give 3H plus ion. 3H plus ion. You know what is the basicity of H3PO2? It can donate only this hydrogen, therefore it is called monobasic. H3PO3 having 2 OH group are there, 2 H plus you can donate, so it is a dibasic one. Its basicity is 2. But here you can be student, it can donate 3 hydrogen atom, therefore it is tribasic one, right? Tribasic one. So the question, which can form 3 series of salt, which can donate 3 H plus ionic compound different salt, that is why option C, H3PO4. Next one. Which of the following element can be involved in p-pi d-pi bonding? Generally, study the general case. Generally, so this is hydrogen family, no? Okay, I think other elements also given. Generally, In a group, in a same group, the first element, it doesn't contain d orbital. It can make only p pi bonding. But next element onwards, d orbitals are starting. It can create p pi d pi bonding. Study like that. The first element in every group doesn't contain d orbital, so it can make only the outermost pp overlapping. But next element onwards, d orbitals are starting, so it can form p pi d pi bonding. So let's see for the element. What is the elements located? You know the periodic table, right? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Then we have sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Which all elements are given here? Carbon, then boron, then nitrogen, then phosphorus. Clear now? These are the first element in the respective group, so it can make only p pi p pi bond. But phosphorus onwards, it can make p pi d pi bond. Answer is which one? Option D. Now, which of the following hydride, which is the strongest reducing agent? That already we discussed. Nitrogen family, I think given, right? Nitrogen, phosphorus, arsenic, antimony, and we have bismuth. Their hydrides are this one. As I told you, what is mean by a reducing agent? Reducing agent is a substance which can donate H plus ion easily. We know that NH3 bond is a very stronger bond. PiH3 is a very weak bond, so it can donate hydrogen easily. So which is the strongest reducing agent? BiH3 option C is the correct answer. Next one. In the preparation of the compound of xenon, N. Bartlett is the scientist. He discovered a red colored compound, right? What is that? O2 plus PtF6 minus. And he finalized that this O2 oxygen molecule and xenon atom having same first ionization enthalpy. So he replaced by O2 by xenon. So Xe plus PtF6 minus. This is the first compound of the noble gas prepared by Bartlett. So Bartlett had taken this compound as a base compound. This is because from why he replaced O2 by xenon, because we know both O2 and xenon having almost the same ionization enthalpy. Both O2 and xenon having same ionization enthalpy. Because of that, O2 replaced by xenon, he made the first compound with a noble gas. Which gas is evolved when urea treated with the sodium hydroxide? What is urea chemically? NH2CO NH2. Right? This is called urea. Which gas is evolved here? Urea, I think we discussed in only one of the reaction for the preparation of ammonia. Answer is option B, ammonia. How? Urea, when we treated with the sodium hydroxide, it can give you sodium carbonate and ammonia gas. Sodium carbonate and ammonia gas. Urea, when you treated with the sodium hydroxide, it will give you sodium carbonate and ammonia gas. So urea, from which you can prepare which gas? Ammonia gas. Now, which of the following is thermally the most stable? Thermally most stable. This is oxygen, sulfur, selenium, tellurium. So oxygen family given. Oxygen, sulfur, selenium, tellurium, polonium. They are hydride. So H2O, H2S, H2SE, H2Te, H2PO. We already discussed that the topmost element, oxygen, is the highly electronegative element. So it is bonded with hydrogen is a stronger bond. So which is highly stable towards temperature, that is H2O. Okay, high thermally stable means H2O. Xenon difluoride has dash shape. XeF2. XeF2. What is the geometry here? All XeF2. There are three lone pair like this. It's having a linear geometry. XeF2 having a linear geometry. Now, in qualitative analysis, when hydrogen sulfide passed through an aqueous solution of salt acidified with a dilute HCl, a black precipitate is obtained. On boiling the precipitate with a dilute nitric acid, it forms a solution of blue color. Blue colored solution is which one? Copper solution, right? Copper 2 plus ion. Addition of an excess of an aqueous solution of ammonia to the solution gives. We studied that ammonia solution we can use to determine the presence of some metal in a compound. What? Ammonia solution we can use to determine the presence of some metals in a compound. Two major examples you may study in the chapter. Copper ion and silver ion you can detect in a compound or not. Copper ion is generally blue in color. That is the definition they given here. It's forming a blue color. When copper reacting with the ammonia solution, it will give you a complex of this copper and ammonia. Cu combining with the 4 ammonia with a charge 2 plus. It's having a deep blue color. The copper 2 plus is a normal blue color. It's become a deep blue in color. CuNH3 4 times 2 plus. Similarly, silver ion you can determine. Silver ion, if you consider AgCl having a white color, in which Ag is in plus charge. When you treat it with the ammonia form a complex with the silver. It will give you AgNH3 twice plus. It is colorless. See, a white colored substance, AgCl, when you treat it with ammonia, it becomes colorless. So you can confirm that the compound contains copper or silver, depends on this observation. So the question, addition of an excess of an aqueous ammonia to the solution gives a deep blue color of which one? CuNH3 4 times 2 plus. Option A is the correct answer. Next one. In cyclotrimetaphosphoric acid molecule. What is cyclotrimetaphosphoric acid? We discussed the formula HPO3 thrice. What is cyclotrimetaphosphoric acid? Only the cyclic one we studied, cyclotrimetaphosphoric acid. What is the structure? Very simple. The ring contains POP bonds. The ring contains POP. This is the bond. This is in the ring. POP. Total there are 3 POP bonds in cyclomet. Then each phosphorus connected to a double bond OH, because oxoacids of phosphorus mean double bond O and OH is compulsory on phosphorus. Here also double bond OH. Here also double bond O and OH is there. Okay. This is the structure of cyclotrimetaphosphoric acid. What is the question? In a cyclotrimetaphosphoric acid, how many single and double bonds are present? This is single bond. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And between OH group also there are single bond. Yes or no? Between OH bond also single bond is there. So 10, 11, 12. There are 12 single bond. How many double bonds are there? 3 double bonds, right? 1, 2 and 3. So 12 single bond and 3 double bonds are there. 12 and 3. 12 and 3. Option A is the correct answer. 12 single bond and 3 double bond. Next one. Which is the first compound of inert gas proposed by Bartlett? We studied that the first compound is Xe plus PtF6 minus. Where is this? Option D, right? Xe plus. If you make it an ion, Xe plus PtF6 minus. Now, what is the geometry of XeOF2? Xe is the central atom. It is having 8 valence electron. It is surrounded by 1 oxygen atom and 2 fluorine atom. Each fluorine need 1 electron to complete octet, but for oxygen atom need 2 electron to complete octet. So total how many bond pair and lone pair on the central atom xenon? 1, 2, 3. There are 3 bond pair and 2 lone pair on the central atom. Shape is what? T-shaped one. How to draw? Xenon, fluorine, double bond O and 2 lone pair. It's having a T-shaped geometry. Alright? XeOF2 having a T-shaped geometry. Now, strongest reducing behavior of H3PO2 is due to. What is H3PO2? Hypophosphorus acid. What is the geometry we studied now? P double bond OH remaining 2 hydrogen. Why it is a reducing behavior? Reducing behavior means it is ready to donate H plus ion. Yeah, it is ready to donate H plus ion. Okay, so low oxidation state of phosphorus. Yeah, what is the answer? Option B, presence of one OH group and two pH bond. Right, because of the one OH group, it can donate then H plus ion. Yeah, it is a reducing one. Okay, option is B. Maximum covalency of nitrogen. We discussed before, maximum covalency of nitrogen is which one? 4. Right, the beginning we discussed. Which of the following element does not show allotropy? Does not show allotropy. You know, carbon-carbon making allotropy or catenation. Why? Because the bond is stronger. Which will not form allotropy, that already we discussed before, nitrogen. Because nitrogen bond is not a strongest bond. It is a weakest force because of electron-electron repulsion. Yes or no? So what is the two reason here, all of you? Two question. Nitrogen cannot form allotropy. At the same time, nitrogen cannot form catenation. Nitrogen bond is weaker. Okay. Next. A brown ring is formed. We discussed one of the question. Brown ring test is used for determining nitrate ion. Which is the brown ring is chemically. What is the test actually you are doing? You will take a test tube, right? You will take a test tube to which you will add your nitrate containing compound NO3 minus. For example, sodium nitrate or potassium nitrate, etc. To which you are adding ferrous sulfate solution. Yes or no? FeSO4. You will do this experiment in laboratory, right? After that, without shaking the test tube, you are going to add concentrated sulfuric acid along the side of the test tube. So let me take the reacting species here. NaNO3, the reacting species is NO3 minus. FeSO4, which the reacting species Fe2 plus. Acid which containing H plus ion. Now let me write the reaction. This Fe2 plus ion reacting with the nitrate ion in presence of the acid, Fe2 plus is converted into Fe3 plus, nitrate is converted into nitrogen oxide, and H plus converted to H2O. After that, in the mixture itself, iron will combine with a 6 water molecule. So it will form FeH2O 6 times 2 plus. First iron combining with a 6 water molecule, forming the compound FeH2O 6 times with Na plus. It will react again with the nitrogen monoxide. So Fe, what all things are there? 1 Fe, 6 water, you are adding 1 NO. One of the, among the 6 water molecule, please remove 1 water and you please add NO there. That's it. One of the water molecule, you take it outside. So what is left? Fe, H2O 5 times this NO with a charge 2 plus. This is what going to form. This chemical compound is known as the brown ring compound. So brown ring compound contain what all things you remember like this. 1 iron, 5 water, 1 nitrogen monoxide with a charge 2 plus. So what is your compound? Option B is the brown ring compound. FeH2O 5 times NO2 plus. Element of group 15. Group 15 is nitrogen family. Nitrogen, phosphorus, arsenic, antimony, bismuth. Element of group 15 form compound plus 5 oxidation state. We studied that the general oxidation state possessed by nitrogen family are plus 5 and plus 3. The topmost element shows plus 5 except nitrogen. Down the group it becomes plus 3 due to we studied inert pair effect. Okay. However, bismuth form only one node. So where is bismuth located? Bismuth is located down. So down element generally shows plus 3, right? But bismuth shows only one compound with a plus 5 oxidation state, which is that. Bismuth generally stable state is plus 3, but it can form only one compound with a plus 5 oxidation state. What is that? Dear student, bismuth is donating only 3 electron generally. If it want to donate 2 more electron to show plus 5 oxidation state, the other element should be highly electronegative element. Then only they can take electron from bismuth. Yes or no? So what is the highly electronegative element here? Oxygen, chlorine, sulfur, fluorine. Fluorine, right? BiFi. That is the only one compound where bismuth existing in plus 5 oxidation state. Next one. On heating ammonium dichromate and barium azide separately, we will get which type of substance here. What is ammonium dichromate? You know, ammonium, NH4 twice Cr2O7. K2Cr2O7 is called potassium dichromate. NH4 twice Cr2O7 is called ammonium dichromate. Ammonium dichromate on heating, you are getting total 3 compound. You know, nitrogen gas and Cr2O3 chromate, and we have water. Similarly, barium azide, ammonium dichromate over, let's go to barium azide. What is barium azide? BAN3 twice, right? Barium azide. Barium azide on heating, you will get barium and nitrogen gas. So in both reaction, what you are getting here, student? Nitrogen gas. N2 in both cases. This is we studied that in nitrogen family in the preparation of nitrogen gas. Next one. In the preparation of nitric acid, we get nitrogen monoxide gas by catalytic oxidation of ammonia. That reaction already we discussed. First step we discussed before in one of the questions. How many moles of nitrogen monoxide are produced by the oxidation of 2 moles of ammonia? In the preparation of nitric acid, we discussed the oxidation of ammonia. Let me write the reaction. Ammonia. When you oxidation means addition of oxygen, we will get the compound nitrogen monoxide along with the water. Remember this reaction? We discussed that this temperature is around 800 degrees Celsius. The question was, what is the catalyst? Study now, platinum, rhodium, wedge. This is the question. One of the I think second or third, fourth question we discussed. The oxidation of ammonium. What is the catalyst we are using? Platinum, rhodium is the answer. Here the question, in this process the oxidation of ammonia, the moles of nitrogen oxide produced by the oxidation of 2 moles of ammonia. Let me balance this reaction first of all. While balancing you will get 4 nitrogen, here 5 oxygen, and here we will get a 6 H2O. 10 oxygen, 4 plus yes, 10 oxygen. You know, as per the equation I can say that 4 ammonia, take a stoichiometry. 4 ammonia giving you 4 ammonia on reaction giving you 4 nitrogen monoxide. Question: what is the mole of nitrogen monoxide produced by the oxidation of 2 moles of ammonia? 4 mole ammonia giving you 4 mole nitrogen monoxide. So 2 moles of ammonia, how much you will give it? 2 moles of nitrogen monoxide, right? Option is fourth one. Answer is 2. The oxidation state of central atom in the anion compound of NaH2PO, central atom. Okay, what is the central atom here? Phosphorus. What is the compound given? NaH2PO2. What is the oxidation state of phosphorus? Sodium, you know, oxidation state is +1. Hydrogen charge is +1. 2 hydrogens are there, so 2. Phosphorus we don't know X. 1 oxygen charge is -2, so 2 oxygen charge is -4. Overall it is a neutral compound, 0. So 3 plus X minus 4 equal to 0. X is equal to +1. Right? X is equal to +1. Option 4 is the correct answer. Which of the following is not tetrahedral in shape? Not in tetrahedral shape. Option first one, let me take it. Nitrogen. Nitrogen central atom, you know, it contains 5 valence electron. Nitrogen, can you see in the compound there is a positive charge. Positive charge is getting by losing one of the electrons. So let me lose one electron. It is surrounded by total 4 hydrogen atoms. Each hydrogen needs 1 electron. Total there are 4 bond pair, 0 lone pair on central atom. Yes, this is equal to tetrahedral geometry. Option number 2. SF4. Sulfur is the central atom. 6 is the valence electron. It is surrounded by 4 fluorine atoms. Yes or no? 1, 2, 3, 4. Each fluorine needs 1 electron. Total there are 4 bond pair, 2 lone pair. 1 lone pair only, no? 4 bond pair, 1 lone pair. You know, 4 bond pair, 1 lone pair, that's equal to seesaw geometry. Seesaw. How to draw? Sulfur, fluorine, 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 fluorine. See, lone pair. Seesaw shape. So that is not the tetrahedral. You can check it Option 1, 3, 4 all are tetrahedral shape. Okay, option 2 is the correct answer. The property of halogens which is not correctly matched. Fluorine, chlorine, bromine, iodine, ionization enthalpy. Yeah, fluorine having greatest ionization enthalpy, right? Because that is the topmost element, smaller size. Fluorine, chlorine, bromine, iodine, electronegativity. No confusion, top to bottom electronegativity decreases. Iodine, bromine, chlorine, fluorine, density. Yeah, down the group density increases. Electron affinity. What is electron affinity? That is nothing but electron gain enthalpy. Electron gain enthalpy order of fluorine, chlorine, bromine, iodine when you consider, dear student, if you want to write the electron gain enthalpy of a halogen family, you please interchange fluorine and chlorine, okay? Fluorine and chlorine, please interchange. Chlorine first. So we will get chlorine greater than, fluorine greater than, bromine greater than iodine. You studied no? Chlorine having high electron gain enthalpy than fluorine. This is the order. So if you want the electron gain enthalpy order of which one halogen, you please interchange fluorine and chlorine. That's it. On answer, the incorrect statement is option D. Among the following molecule, these having same number of lone pair of xenon are. First compound is given XeO3, second compound is given XeOF4, and third compound is given XeF6. Yes, student. Here xenon is the central atom, xenon outermost electron, 8 are there. Here also xenon is the central atom, 8 are there. Here also let me take xenon central atom, 8 electron. Here in this, there are 3 oxygen atoms surrounded, right? 3 oxygen atoms. Each oxygen requires 2 electrons to complete the octet. So there is 1 lone pair left. Here 1 oxygen atom and 4 fluorine. 1 oxygen, 2 electron require. Each fluorine require 1 electron. Again 1 lone pair. XeF6 means total 6 fluorines are there. Each fluorine needs 1 electron. Again 1 lone pair. So I think all of the compound having 1 lone pair common. So 1, 2, 3. All of them containing same number of lone pair. Now, XeF2, XeF4, XeF6, what is the number of lone pair on xenon? Very easy. XeF2, XeF4 and XeF6. Xenon is the central atom again. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Here 1, 2, 3, 4, 5, 6, 7, 8. Here it is surrounded by only 2 fluorine atoms, so they let them take 1 electron. Here they connected through 4 fluorine atoms, let them take 1 electron. And here they are connected by 6 fluorine atoms, let them take electron. So total how many lone pair in XeF2? 3 lone pair, here 2 lone pair, here 1 lone pair. So 3, 2, 1, 3, 2, 1. Option D is the correct answer. Number of lone pair only, simple. Now, which of the following is the correct statement? Fluorine having higher dissociation energy than chlorine. No, right? We studied that fluorine-fluorine bond is a very weaker bond compared to chlorine-chlorine. So that is the wrong statement. Fluorine has higher electron affinity than chlorine. That is the wrong statement. Yes or no? We discussed now chlorine having high electron affinity. Just a previous question. HF is a stronger acid than HCl. HF is a stronger acid than, once again all of you, question number 1. Fluorine have higher dissociation energy than chlorine? No. Fluorine has higher electron affinity than chlorine? No. HF is a stronger acid. HF is a stronger acid? No, right? HF is a stronger bond. HF is a stronger bond. It cannot leave hydrogen faster. It is a weak acid. Boiling point increases down the group in halogen. Boiling point increases down the group in halogen. Boiling point, if you consider halogen, fluorine, chlorine, bromine and iodine, boiling point order I told you how to remember. First one, we can say that, the greater boiling point increases down the boiling point, mainly affecting which data, the size. One is molecular mass, one is their bonding. So greater mass is for which one? Greater mass is for iodine, right? Greater mass is for iodine. And fluorine bond, it is the weakest bond also. So boiling point increases down the group in halogen can be correct. Yes or no? So D can be the answer. Now, which of the four strongest acid in the following? HClO3, you can calculate the oxidation state here. HClO3, chlorine is in, let me just calculate the oxidation state first. Okay. Hydrogen oxidation state is 1, chlorine X, 6 oxygen minus 6, 0. X will be plus 5 state. Here also hydrogen 1, chlorine X, A4 oxygen minus 8, 0, X equal to plus 7. Plus 7. Here 2 hydrogen, 1 sulfur and 3 oxygen minus 6, therefore X equal to plus 4. Here 2 hydrogen, sulfur minus 8 equal to 0, X equal to plus 6. We know greater the oxidation state, greater will be the acidity. Where you can identify greater oxidation state plus 7 for the halogen or sulfur. Which one? Option B having greater acidity. Now, which of the following is a polar molecule? Polar molecule means they having a dipole moment. Polar molecules mean they having a dipole moment. SF4. Let me take SF4. SF4 structure will be here. All we studied that it having a seesaw geometry. It having a seesaw geometry. You can see this fluorine here, left side, this fluorine pulling here. They will cancel each other. But these fluorine and these fluorine, they will be a resultant. So there is a resultant mean it having a polarity or dipole moment. Option A is a dipole moment. You can check with the SiF4. SiF4 having a tetrahedral geometry, XeF4 having a square planar geometry, BF3 having a trigonal planar geometry. In all these cases, dipole moment will cancel each other, dipole moment will be 0, they are non-polar. Okay, option A. In which of the following arrangement given sequence is not strictly according, which is incorrect one? HF to HI acidic strength increases. Yes or no? Yeah. HF to HI bond is weaker. You can easily donate hydrogen. Correct one. H2O, H2S increasing order of pKa. What is pKa? We studied that Ka value increases, their acidity increases. That is called ionization constant or dissociation constant of an acid. Ka value increases, acidity increases. pKa value increases, we can say acidity decreases. Acidity decreases. Let me check the option B. That is given there H2O, H2S, H2SC, H2Te. H2O bond is a very stronger bond. Down the group it will be weak bond. So which is the most acidic one? Most acidic one is H2Te. So its Ka value will be very greater, pKa value will be very lesser. But what they given, it is increasing order of pKa, which means H2Te having highest pKa. No, it having lowest pKa, that is more acidic. So that is a wrong statement, our correct answer. Remaining you can check it, all are correct. Now, alpha and beta form of sulfur you studied now, rhombic sulfur and monoclinic sulfur are at equilibrium at a temperature known as. What is the temperature in alpha and beta sulfur we discussed? That is called it is called option C, transition temperature. How much is that? 369 Kelvin. One of the questions we discussed now before. Which of the following statement is correct about the hydride of group 16? Order of acidic strength. We studied now from H2O to H2Te, bond become weaker, easy to donate H plus ion, acidity increases. Correct. Order of thermal stability. H2O bond is a very stronger bond. H2O bond is a very stronger bond. Thermal stability greater. Correct one. Order of melting and boiling point. H2O having greater one. And oxygen, sulfur, selenium, tell you this order is correct. Okay, dear all. Because boiling point and melting point, I told you it is compared not only the bond strength, depend on their mass also. H2O having greater boiling point because of greater force of attraction. H2Te having next one because of greater mass. So all of the above are correct statement for this one. What is the only one oxoacid of sulfur which contain lone pair? The first oxoacid of sulfur we studied, no? What was that? H2SO3, sulfurous acid. What is the geometry we studied? S double bond O, OH, OH, there is a lone pair. Lone pair containing the only one oxoacid of sulfur we discussed in 12th, that is what? Sulfurous acid. Option A, sulfurous acid, that is the correct answer. Okay, sulfurous acid. So dear student, around 100 question we discussed about the chapter P block element. So for the term 1, all the 6 chapters video or the 100 MCQ discussion that we already completed. So all of you prepare very well for your examination and wish you all the very best for your upcoming term 1 examination. We have to make a good result. I hope I will wish you from my bottom of heart. I will pray for each one of you and you will definitely get each and every question and the correct answer among the 4 options, the correct answer immediately without any mistake or fail. Okay, thank you all. Wish you all the best.